Hello everyone, this is LeetCode 108, convert sorted array to binary search tree. So we're given an integer array nums where the elements are sorted in ascending order, convert it to a height balanced binary search tree, right? So there are two key pieces of information, right, in the problem statement, right? We have a binary search tree that is height balanced, that's going to be our output, right? And height balance is a binary tree. A height balanced binary tree is a binary tree in which the depths of the two subtrees of every node never differs by more than one. That makes sense, right? Because if we have a binary search tree, we don't want, like, for example, we have a starting node. We don't want all the nodes to be on the right child or to only have right subtrees, but no left subtrees, right? Like a lopsided tree. That would not be a binary search. That would not be a very good binary search tree. So, yeah, right. For example, this -3 should never be a right child node of this 9, right? It should be right here. So it has to be height balanced, right? Pretty simple. And on top of that, we have elements that are sorted in ascending order, okay? Now, a lot of times when you're given an input that is sorted in ascending order, you should always ask whether you can use the binary search algorithm, right? Because a lot of times the answer is yes, especially in this case. Obviously, the answer won't always be yes, but a lot of times the answer is yes, because a lot of times when they give you a sorted input, it's for a reason, right? So the reason this input being sorted is helpful, right? And they didn't have to do this technically. They could have forced us to sort it ourselves, but they were generous and they gave us a sorted input. And the reason it's helpful is because this root node here, right? The starting root node, when we have this array, we have to pick what is our root node, right, for our binary search tree. Would we want to pick -10? Well, no, because all these numbers are greater than -10, right? And we would have like a lopsided tree. Would we want to pick 9? No, because all these numbers are less than 9. And again, we would have a lopsided tree. We want a height balanced binary search tree. So, roughly speaking, we want, right? We want to pick a node such that, half of the nodes are on this side, half the nodes are on this side, right? Roughly speaking. So it stands to reason that we will want the node in the middle of this sorted array, right? So the way to get the middle element is we could do binary search, right? So we would, because again, this input is an array. So we'd have a left pointer at the start, a right pointer at the end of the array, and we calculate the midpoint, right? That's our node, our starting node, okay? Now, how do we construct the left and the right subtrees? Well, we have this middle node here, right? Everything to the left is going to be in the left subtree. That makes sense. But how do we know what node goes here? Well, we could do binary search again, right? Our left pointer is still here, and the right pointer, right, we could put it to one to the left of the midpoint and use basically the left pointer and mid -1 and calculate the midpoint again for whatever node goes here. Likewise, same logic, right? Our right pointer is here. Initially, our midpoint is here. We could do mid +1 for the left pointer, and the right pointer again is here. And we could use these two pointers to calculate the midpoint again and find out what should go here. And we can recursively do that to construct our entire tree and make sure it is height balanced, okay? So we're not going to do all our work in this function. We're going to have a helper function, but we are going to call this, we are going to call the function that we're going to make. So we're going to have a function called construct tree, right? And we're going to have a left pointer, which is going to start at 0. Our right pointer is going to start at the end of the input array, right? So we do nums dot size -1, and that's at the input. Okay. Now let's construct this helper function. Okay. So we're going to say tree node. I'm going to say construct tree, and we're going to have basically an input that is the left pointer, the right pointer. Again, these are the indexes, right? And the input array, because we need to use it, obviously. Okay. And so if at any point the left pointer is greater, right? If the left pointer is greater than the right pointer at any point, we know that we have an error, right? That should never be the case. So at that point, we just return null, right? Because we Can't calculate the midpoint if the left pointer is greater than the right pointer, right? So now let's calculate the midpoint here, okay? We have a base case done. Now let's calculate the midpoint. I'm going to say int mid is equal to left plus right divided by 2. Whoops, divided by 2. Now, this is not good, right? Because we're using C++. And C++, right, you can have overflow. So we need to rewrite this to left plus right minus left divided by 2. That way we don't have any, overflow errors. Okay, so now let's calculate the midpoint. Now that we find the middle index. So let's create a root node. And we're going to say new tree node. We're going to say nums at the mid, right? We're going to construct the root node. Okay. So for example, we have the index, initially we would have 0, 1, the index 2, right? And we create the node at the second index, which would be 0 in example 1. Okay, now from here on out, we need to do this recursively to the left subtree and the right subtree, right? So we're going to say left is equal to construct tree. And again, right, when we're at the when we're handling the left subtree, right? The left pointer is already here, which is good, but the right pointer needs to be not here, but here. So that would be mid minus 1, right? So we would do left, and the right pointer should be at mid minus 1. Right subtree, very similar, right? The right pointer is here, which is good, but the left pointer, the mid pointer is here, but we want the left pointer to be here. We don't have to move the left pointer, we can just use mid. So we could do mid plus 1, right? So that we handle the boundaries here. Okay. Whoops, let me highlight that perfectly. There you go. So we would do mid plus 1 as our left pointer, and our right pointer should just be at the right, where it is now. So we do mid plus 1, right, and nums, right? And then at the end of that, we'd return the root. Okay, and we're going to recursively do it, like build out the tree just this way, right? So, yeah. Pretty clever approach. I definitely could not come up with this the first time I came across this problem, so. But, if you couldn't either, that's fine. That's kind of the point of practicing. Yeah, I hope this helped, and as you can see, right, I submit, and it works. No errors or anything, so I hope this helped, and yeah, I'll see you in the next one.